Hello, we are now starting with our HW03 question for numeric manipulation. This is a fairly easy question, so let's get started. As you can see, I have already named my file as HW03 for numeric manipulation. Alright, so num1 is a randomly generated variable. As you can see from the given script, you have already been given a randomly generated value for num1. So I'm going to take this, copy it, and paste it in MATLAB right here. Okay, write a code so that if num1 is 0, add 15 to num1. So I've been given a condition, and then if that condition is true, I need to perform an action. Therefore, I need to use my if statements. So I'm going to write my if statement, and what am I checking for? If num1 is 0. So num1 equality sign 0. This is my condition, and what's my action? Add 15 to num1. So num1 equals num1 plus 15. Okay. Can I end my if statement? No, because I have more conditions to follow. So the next condition is if num1 is even, excluding 0, multiply num1 by 5. How do I know how to exclude 0? I have already done it because my first if statement is checking if num1 is 0. How the if statement works is if the first condition is true, it's not going to check the following conditions. So if my num1 is actually equal to 0, then it's not going to check if that number is also even, right? So I'm already excluding 0. And what's my condition? I need to check if it's even. So going by the if syntax, I'm going to write else if. So else if. And how do you check if a number is even? You need to divide the number by 2. And if the remainder is equal to 0, that means the number is even. So for that, I'm going to use the rem function. That gives me the remainder. So rem num1, 2 double equal to 0. Okay, and my action is multiply num1 by 5. So num1 equals num1 times 5. Okay, and my last condition is if num1 is odd. Do I need to specifically check if num1 is odd? Not exactly, because if a number is not even, then it's automatically odd. And we've already checked for 0. Okay, so I can directly use my else. Else num1 equals num1 times 10. Perfect. And I can end it because I have no more conditions. Okay. Now we need to check if the resulting num1 is divisible by 3 and store logical 1 in variable div3. If it is, if not, store logical 0. So I'm going to use my if statement again because I'm going to check for something, and if it's true, then I need to assign a value to div3. If not, assign a different value to div3. And how do I check if a number is divisible by 3 again? I need to use my rem function, and if the remainder is 0, that means it is divisible. And if the remainder is not 0, that means it's not divisible. All right? So I'm going to say if rem num1, 3 double equal to 0. And what do I need to do? Div3, store logical 1. Okay, div3 equals logical 1. And this already checks the new num1 because all of these statements are already executed before. Okay, and I'm going to write else div3 equals logical 0. So now this is not incorrect, but at the same time, you will see MATLAB is giving me an error message, and it's asking me to use true or false instead of logical 1 or logical 0. So I'm going to listen to MATLAB, and I'm going to use true. True. And I'm going to say false. It's going to give me the exact same answer, so that's not an issue. Okay. Actually, I have run this before, so let me clear it once, actually. Yeah. Okay. I will run this again. You can see I have my div3 value, I have my num1 value. Perfect. So I'm going to copy this, put it right here. There we go. Run my script. Perfect. And submit. Great. We're starting with HW03 part 5. Repeating elements and mirrored matrices. This was definitely one of the most asked questions during office hours, and a common mistake that multiple people made was for part A, they were creating different loops where they looped from 1 to 10 and accordingly repeated the elements. Why this solution is not practical is, what if I had changed the value of n from 1 to 10 to 1 to 100 or 1 to 500? It's impossible for you to sit and write so many little loops to get your question done. Therefore, we need to find a solution that is independent of the value of n and would work for any size of q. All right, so let's get started. Let's look at the first question. Before that, I'm going to take the script here, copy it and paste it right here. As you can see, I've already saved my file. Okay, part A. Given the 1 by n row vector q, create a 1 by 4n row vector vec A, where a copy of each element in q is quadrupled. For example, when q is 1, 5, 7, 8, vec A is 1 repeated 4 times, 5 repeated 4 times, 7 repeated 4 times, and 8 repeated 4 times. So an important thing to note here is, irrespective of the size of q, so if my q was say 1 by 5 or 1 by 7 or 1 by 2, my vec A would always have the elements repeated 4 times, right? So that is always applicable. And you should not be using the built-in function rep elements. That's okay. How I like to approach this question is, I like to refer to Professor Yim's solution right here in the discussion board. So it's homework 3, question 5, and this is his solution. And I'm also going to pull up my notes right here. Okay. So as you can see, vec is 1 and 2, 1 and 2 concatenated vertically in the row direction. So I'm going to assume that q was initially 1, 2, a row vector, a 1 by 2 row vector, and it had the values 1 and 2, right? And when you concatenate a q vertically like this, it becomes a vector just as it's been shown, okay? The size of q is not an object. It does not affect how the concatenation works, because my q could be 1 by 4, 1 by 5, anything, and this is how my vector would look, right? The same elements would be in the same column, and all my elements of q would be in the row. Okay, now we see that Prof. Hume has used linear indexing to call all values of this particular vec. How does linear indexing work? It works like a snake, right? So it goes column-wise. It goes through every column top to bottom. And if you think about it, when you're concatenating q in the vertical direction, the same elements are always in the same column. And that's the first thing that will be outputted when I'm using linear indexing, the first column. So now let's use that knowledge and try to apply that for our question. So our question, I need my elements of q to be repeated 4 times. So to get all my elements of q and repeat them 4 times and have the same elements written in the column direction, what I'm going to be doing is I'm going to initialize. First, let me write a comment. This is part A, right? I'm going to write a comment. I'm going to write a temporary matrix and concatenate q in the vertical direction 4 times. So this. Okay, I am going to run this quickly so you can see how q looks. That's my temporary matrix. That's my q. Okay, it's taking a while to load. Okay, so that's my q, and that's how my temporary matrix is going to look. So it's repeating q 4 times like this, and all the same elements are all in the same row, right? So now what I'm going to be doing is I'm going to refer to this next step, this particular syntax, and use linear indexing to define my vec A. So for vec A, I'm just going to say temporary matrix. Oh. Now let's look at my solution. I'm going to run this. Now vec A is a column vector. It's an 8 by 1 double in this scenario. But do I want a column vector? Not exactly. I want a row vector. So to do that, I can simply transpose. Okay, and that's it. That's all you need to do for part A. Another way to do part A is I will once again initialize my temporary matrix and concatenate q in the vertical direction. And after that, instead of using linear indexing, I can also use, if you remember, you've been taught the reshape function. I can just use that. I can use reshape, and I can say maths sorry, temp mat. And how would I reshape it? I would reshape it into a 1, comma, 4 times n vector, because that's my final vectors. That's the size of my final vector that I want, right? It has to be a 1 by 4 n row vector. And okay, I'm gonna comment this out so I can run the other one. Comment. Okay, if I run this, I am also gonna get my desired value. Do you see how 21 is repeated 4 times, 4 is repeated 4 times, and 11 is repeated 4 times, 23, 20, okay? So both of these codes are completely fine. It's up to you which one you're more comfortable using. Just because you cannot use the built-in function rep_lm does not mean you cannot use reshape. It's just that particular function that you need to avoid. You can always use other functions, okay? Let's move on to part B. So remove the appropriate elements from vec A so that instead of each element of Q being quadrupled, it's only tripled. So in this particular question, I need to actively remove elements from vec A. So I need to change vec A. So what I'm going to be doing and store this in a new vec B. So I'm going to define new vec B and assign vec A to it. Okay, and now, oh, not vec. Okay, and now I'm going to make edits to this new vec B because I don't want to make changes to vec A. That's a solution we're checking for, right? Okay. And okay, so now I have my vec A, which should look something like this. Let me write something here. Okay, so my part B, oh, oops, anyway. My vec A should look something like this. So I have my, let's say this is 2 repeated 4 times. Then I have 1, 2, 3, 4 repeated 4 times. And I have some other number after that repeated 4 times, right? And instead of being quadrupled, it should only be tripled. So I want to delete every 4th element till the end of vec A, right? And how do I do that? How do I delete every 4th element? You know, to delete, you need to use something like, oh, my bad. If I'm deleting, say, the 4th element of mat A, so I write something like mat A4 equals blank, right? That's how you delete a value. And what I want to delete here is every 4th element, so of vec B. So I'm going to say vec B, and I'm going to be using the step function here. So I start at 4, I go up by 4, and I go till the end, right? Because here I'm starting at index 1, 2, 3, 4, 5, 6. Oh, that's not 6, my bad. I was thinking about 8. Okay, 5, 6, 7, 8. So I'm starting at 4, I'm skipping 4, and then I go till the end. And this is all deleted. So now when I delete these numbers, I'm going to be left with the same elements repeated 3 times instead of 4. Okay, so that's exactly what we write in here. So vec B 4, 4, end equals to blank. End. Okay, now moving on to part C. Create a 1 by 3n minus 2 row vector called vec C, which is a reverse and forward vector in which 1 in the middle of the mirrored vector is repeated n times. Alright, so for this question, my vector should look something like this, right? It should have the reverse, it should have the ones, and then it should have the forward. If you look at the example, that's how it is. It's 4, 3, 2, 1. Then I have my ones, and then I have my 1, 2, 3, 4, right? If you take a look again at his solution right here, you know how to make a forward vector. You know how to do 1, 2, 3, 4, 5 till whatever n is. You know how to make a reverse vector. You know how to come down from n to 1. And you also know how to make a vector full of ones. You use the ones 1 comma n function, right? So that is exactly what we're going to be doing here. So I'm going to define a forward. What's the first thing I need to do? I need the reverse vector first. So I'm going to define reverse. And I'm going to start at n minus 1, go till 1. My middle would be ones. Okay, now if you look carefully, 1, 2, 3, 4. So it does contain the exact same number of ones as my n value, right? So my n is 4. However, when I'm using this reverse value, I start at n and I go till 1. So I'm already including this 1 here. So a way I could avoid repeating ones is I end this at 2. And then in this particular ones, I say 1 comma n, right? You make sure you don't exceed the number of ones in every vector, okay? And my forward is 1 to n, but as you can see again, we've included all the ones here. So I should start at 2 instead of 1, okay? So I have my reverse, I have my middle and my forward. So what is my answer going to be? My answer is going to be vec c is equal to, and just concatenate all of them in the horizontal direction. Reverse, middle, forward. There you go. And that is all. Another alternative for this, instead of defining 3 variables like reverse, middle, and forward, I can directly write vec c equals this space this space this. Okay, I do not have to declare all of them as variables. It's up to you though. Whatever you find more comfortable, that's how you should write your code. Okay, I'm gonna comment that last part out. And I'm gonna run my thing. Okay, take a look at the answers. Okay, now for this one, what I'm gonna carefully take a look at. So it says my vec c should be a 1 by 3n minus 2. What's my n value? It's 10, perfect. And 3n minus 2 is what? So 3 times 10 is 30, minus 2 is 28. Is that what my vec c is? Perfect, yes, so my vec c is correct. Okay, I am gonna copy all of this and I'm gonna paste it right here. There we go, submit. All right, perfect. Hello, we're now starting with our final question for this homework 3 question 6 donut store. As you can see, I've already saved my file here as homework 3 question 6 donut store. This is not a hard question, however, this has been marked at 3 stars, essentially because this is a really important question and you will see different variations of this one being repeated in future homeworks as well as quizzes. So it's really important to pay attention to the question, understand how it works, so in the future when it's made harder and there's different changes being introduced, you will be easily able to replicate your code and adjust your answers according to the new questions. All right, so let's go through the question. A raffle will take place at Bianca's donut store. Each customer receives a 10-digit number. Okay, here you can see that x1 is a random 10-digit number which is already generated for you. So I'm going to take this, I'm going to copy the script and paste it right here. Okay, to win the prize, there's 3 different conditions. The first condition is the digits at the 5th and 6th location are even. So what I'm going to do is I'm going to introduce a variable called condition 1. So COND1, and I'm going to say condition 1. Okay, so the digits at the 5th and 6th location are even. How do we check if a digit at a particular location is even? To reference a digit at a particular location, I need to write something like x1 bracket 5, right? So this is the the digit in the 5th location in vector x1, right? And how do I check if it's even? I use my rem function. So rem x1 5 comma 2 should be equal to 0. This is the way I check if it's even. And for the sixth location, I use the exact same thing. And except for 5, it's going to be 6, right? Because I'm checking for the digit in the sixth position to be even. And how do I connect these two statements? The digit in the fifth and, that's the keyword, six locations are even. So I'm going to use my and operator in between. Okay, so this all together is my condition 1. What is my condition 2? The last digit is not 5. Okay, so let's define my second variable, condition 2. The last digit, so I'm going to say x1 end is not equal to. So for not equal to, my symbol is not equal to 5. Okay, and what's my third condition? It's the second digit is larger than the first digit. Okay, so here is my condition 3. x1 2 for the second digit should be larger than the first digit. So x1 1. All right. So here are my 3 conditions. Kasturi received a 10-digit number and the number is stored in x1, which here, right here, and that's the one I'm using for all of my conditions, right? If Kasturi can receive a price, assign true to a variable named isWin, otherwise assign false to isWin. So since I have my conditions and I have an action accordingly, I'm going to use my if statement. So if, to win the prize, Kasturi needs to satisfy all the 3 conditions, right? So what operator do we use when we need multiple conditions to all be true? The AND operator, all right? So condition 1 and condition 2 and condition 3. So only if every condition is satisfied, Kasturi is going to win. So isWin would be equal to true, else isWin would be equal to false, and end my if statement. Now I could use the if statement. However, you do realize that this answer, if it's true, then isWin is going to be true, and if this is false, isWin is going to be false. Another way I could write this whole thing is to directly assign this value to my isWin, right? Because if Kasturi actually satisfy all these 3 conditions, then this particular statement is going to come out as true, and which is the value of isWin. And if not, then it's going to be false, which is the value of isWin in that scenario. Okay, so optional script. I'm just going to write this as a comment so you can refer to it and you can opt for whichever one you're more comfortable with. Okay, so isWin equals condition 1, oh yes, condition 1 and condition 2 and condition 3 right there. Okay, so instead of writing this whole thing, you can just write this one line. Okay, and that's all. That is my code. I'm going to run this. Just dragging it, everything looks fine to me. I am going to, not this part, yeah, just this. Copy this, paste it right here and submit. Perfect.